Hello, this is a demonstration for lab number 3, which uses a tank, but this time it's using a mixer and 2 solenoid valves to add juice and goo, and a solenoid valve to drain out the juice and goo. It has an overload to represent an overload from the mixer motor. Okay, and a mix timer. So this is going to be the numerical value from the accumulator. Same thing for the juice valve and the goo valve. These turn it on and off, and these will indicate the numerical value of the timer. The start button is normally open. Stop is normally closed. The overload contact is also normally closed. And this slider is going to represent the tank from being empty to all the way up here to being full. And you'll notice that the two sensors here, the low level sensor and the upper level sensor, are being run by a second program, but when it reaches, I believe, about a level of 2.5, and for the upper, let's see what it is, 8, I think 8.5, 8.6, it causes that sensor to come on. Now, the whole goal of this system is to fill up the tank with a mixture of juice and goo at a certain proportion. When it gets to the top of the tank, it should mix for 5 seconds and then begin to drain. And then when it does get to the bottom, it's going to restart the system. Anytime stop is pressed or anytime an overload condition occurs, all of the outputs should be turned off or disabled, and the juice valve or the goo valve should remain at the time it was at, and it'll restart from where it left off. So let's go through this and see how it works. So we'll start with the mix down at the bottom. Okay, and the first thing to do is get rid of that overload. We don't want to start with an overload, and press the start button. And as soon as that happened, you see that the juice and the goo valves alternate, adding a mixture. Now we have to simulate that the tank is increasing in level, so we go up a little bit, keep going, hits the lower sensor. The lower sensor comes on, but doesn't stop because we're not full. Hits that middle point, and same thing, doesn't stop because we're not full. But let's say we stopped the system or we had an overload. Let's simulate an overload. Okay, an overload occurred. It was in the process of adding juice, okay, for the first few milliseconds. And if we restart, it should remember that it was adding juice and it should continue that. And I'm going to press the start button. Oh, sorry, have to remove the overload. Press the start and it continues. Same thing if I press stop and it's in the process of mixing. We'll do it right when it hits the goo. So it was about 0.6 seconds into doing that. And when I press start, it should continue with the goo valve, and it did. So let's go all the way to the top. The mixer comes on because we're at the top. It's timing over here. After 4 seconds, the drain automatically comes on and we come back down. Same thing, if we were to stop here, it should remember what it was doing. When we get to the bottom, the tank's empty, it should start to fill again. And I just want to go through one more step. If we get to the top, and I'll have to do that again. If we get to the top and press stop, we want that mix timer to hold its value. And as soon as we press start again, it'll continue from where it left off. Okay, what's important to also understand is anytime we have a motor overload, all of the output field devices turn off. And the field devices are items such as the juice valve, the goo valve, the mixer motor, and the drain valve. Those are all the field devices. Input field devices would be the start, the stop, the lower level sensor, and the upper level sensor. Okay, I hope you enjoy writing the code for this program, testing it. Take a little bit of time to go through everything so that it seems to make sense. In this second part, I'm going to show you a little bit of the HMI. And the HMI is what's running in the background. So I'm going to go up here and press stop first of all. And the HMI was written a couple of years ago or a year ago, and it's designed to simulate a system. But I want to show you a little bit of what's happening in the background. So I'm going to start off by moving these buttons over to reveal another button underneath. That's important for this one. And what I would do to see, for example, the variable name that's used in the HMI is click on it, right click, and then go to Properties. And I'm going to move this window into here. And the property is a momentary push button. Okay, it's normally open, and the connections to that is called start. Okay, so we can see that that's happening. I'm going to do the same thing for the stop. Open it up, bring that window into here so we can see it. And it's a normally closed, and the name is stop. Okay, so stop and start. Next one I'm going to open up is the numeric for the juice valve. So right click on that, go to animation or connections. Actually, I can go there. It tells me that it's a numeric display and it's displaying the juice valve accumulator. So it's tied to that variable in your main program. It will only display if your main program uses that variable. Same thing for the goo valve. Go to connections, drag it into here, and it's goo.accumulator. The mix timer, just drag it into this window so you can see it, and it's under mix_timer.accumulator. So now, the next thing I want to show you is all of these kind of green squares that were put into the program, and they light up a brighter green, and they are called animations. So let's look at how they work. So I'll click on the juice valve animation. You got to make sure that you're connecting onto that one. And I click on animations, and it's color animation, and it brings up this box that tells you, for example, that it's a certain color when it's not true. So when it's 0, it's kind of a light gray. When it is true, it's green. And the variable is called juice valve, and it's called animation color. And there's a few of those. So that was for the juice valve. This is for the goo valve. So go to animation, color. It might have been off screen, but same thing, but there's the variable, goo valve. Let's do it for the mixer motor, animation, color, and mixer motor. And then the drain valve, same thing. It's under animation, color, and drain valve. Okay, I think I've covered those. Now the sensors here, they are same thing, animation, color, and it's called upper sensor, and the other one is called lower sensor. You don't need to do anything with this shutdown. It's not required. Okay, and this is a slider. Oops, I shouldn't have changed the position of that, but let's just look at how that slider works. Okay, if I right click on that and go to animation, and my recording button's in the way, so let's just try that again. We go to animation, and it's called vertical slider. And some of the information that's in here tells the system how to respond to the vertical slider. So it's called level, and the minimum value is 0, the maximum value is 10. And what it does is as it moves vertically through the minimum value of 0 to 336, it's a pixel position on the screen, it causes the value to change. Okay, this is something I may go over a little later on, but I'm going to close this. And the bottom number is the numerical value for level. So we can actually go to connections, see the connection, and that's level. Now, the other thing to be aware of is that some of these tags are called global tags, and other tags are called, well, let's just go back to the program. Those global tags can be seen by any program that uses the various tags, whereas certain tags only belong to the program that you are writing. Okay, and that's another topic that will be covered later on. So once we have revealed these, let's just move them back to where they should be. Okay, and so I hope that gives you a little bit of information about using those tags. Hello, I wanted to show you some examples of the differences between controller tags and local tags on the PLC. They're very different, and we'll see the differences here. So a controller tag represents a tag that can be seen by any of the programs in your main task or your system. The controller tags, in this case, are actually the hardware tags. So for example, the push buttons and the lamps on the display can connect to these controller tags. And the addressing for these controller tags is shown here. So they will start off with local, meaning attached to this machine, they're not networked. Then a colon, the number 1 to indicate it's slot 1 on the system hardware, another colon, the letter I indicating it's an input, a dot to separate, and then data, meaning it's a group of many bits, but we've identified just one bit. So this is a Boolean tag, okay? And it's actually pointing to the hardware. And there are 16 bits that we can connect to. Now these are the inputs. And clicking on this little symbol, I can minimize that. Now I go to the output. So these are all the 16 bits combined together right here. They're grouped in 4 bits with an underscore separating them, but I can open them up to see each individual bit, and we see them here. So this is telling me that currently output data 0 is off, this one's on, or energized, this one's off, a whole bunch of them are on. So you could actually control them here because I'm in run mode at this moment in time. Now, if I go to parameters and local tags, that's different, okay? If I go over to here, and I want to look at the local tags for the level sensors program, there's actually no tags. They're actually in the controller tags. And let's see if we can find them. And there's just, I think there's just not many of them. I don't know if you can see those because I might have to kind of minimize that screen. So now that I've changed the windows, you can actually see them here. So level is a real value. Real values are values that have not just an integer part, but they have a fractional part. So 0.22, 1.23 would be examples of real. So things like voltage, temperature, pressure would be real values. Down at the bottom, these are also controller tags. And I've called them level sense, upper sensor and lower sensor. But they're Boolean. Their data type is Boolean, but they're shown in a decimal format. So right now, both of these sensors are off. But if I manipulate the HMI, those levels will change and the sensors will change. Let me just do that. So I'm back here in the HMI. I'm going to run the HMI. I believe the program is running. So I'm going to move this up. And the lower level sensor turned on, and we're at 4.7 volts. So let's go back to the tag. And now you can see in the tags that the voltage value has changed, and the lower sensor is true, the upper sensor is false. And there actually is a program controlling that. So here I have a little bit of the HMI and a little bit of the control program. So as I move the slider on the HMI, and they flip back and forth because they're sharing the same screen, but you'll see that the value changed and so did those voltage values. So what this program is doing is just saying if level is greater than 2, okay, if it's comparing level with the number 2, if it's greater than 2, turn on the lower level sensor, and if the level is greater than 8.5, turn on the upper level sensor. Okay, that's all it's doing in this example. So let's maximize this again. And so this is a program that's given to you. It manipulates those tags so that in your main program, you will be able to use it. So let's look at the tags in the main program. So these are called parameters and local tags. And there aren't many of them, but let's look at the ones that are there. All right, here are the tags in the main program. And if you use the templates, these tags will already be there. And notice the different types. Okay, there's a Boolean, there's timers, mostly Boolean and timers. And when you get to the timers, one of the things you may want to do is to open them up, because within that, it tells you the different parts of the timers. So these timers are made up of mixed timers, so that's the timer type, but within that, there are a group called members. And the members are identified because there'll be a decimal point in the tag name. And the members are things like the preset, the accumulator, the enable, the timer timing, and the done. Make sure that you understand each of those bits when you're working with your program. For example, TT, timer timing, tells you that this particular timer is running, okay, and the value will increment. So you can keep track of that. The preset is in milliseconds, so it's telling me that my timer's preset is 4,000. The accumulator is the current value of the timer. This tells me that the rung input to that timer is either true or false. And when the timer has completed, the done bit will go true. Okay, so these are useful to know. So there is a GOO timer, a juice timer, and a mix timer. Now, you also have to understand which bits are output devices. So I've indicated that. The drain valve is, the solenoid valve, the juice valve is, the mixing motor. But the inputs are the overload, the start, and the stop. Okay, I hope this helps out with lab number 3. Thank you.